So last thing we're going to have here are our half-angle formulas where, because they're a little bit pickier, I don't want to risk having there be any ambiguity as a result of my poor handwriting. But what we can do here is if we have things of form sine of some angle over 2, or cosine of that angle, or tangent, we can write that as, for sine of alpha over 2, plus or minus the square root of 1 minus cosine alpha over 2, where that measurement in terms of being positive or negative doesn't come from the square root idea as much as it comes from understanding where that angle lies in the plane about whether sine should be positive or negative. Similarly, for cosine, we have the square root of 1 plus cosine alpha over 2. And then for tangent, we have plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. So you can actually see these coming almost directly with some rearrangement from the formulas we've seen so far, just in terms of slightly different things to talk about slightly different relationships. Where in particular, I'll pull over here that there are alternates for that tangent one that are a little bit cleaner. We can say that tangent of alpha over 2 is either 1 minus cosine alpha over sine of alpha, or sine of alpha over 1 plus cosine of alpha, depending on exactly what we need and depending on what our angle is. But anyway, let's look at an example for how we can use this in terms of something we've actually seen before. So for this, we want to use the half-angle identities, and sine of 30 degrees equals 1/2 to find sine of 15 degrees. Now let's remember that earlier on we actually found this measure, and now we'll see a different way that we can get it. So if we have that sine of 15 degrees, this is essentially the same as sine of 30 degrees over 2, where a different way we saw this was as sine of 45 degrees minus, oh, not sine there, that should be just a 30 degrees. And we used the difference of angles formula. Well, in this case, we'll use the half-angle formula. So we can pull this out in terms of that relationship and get that sine of 15 degrees is equal to the square root of 1 minus cosine of 30 degrees divided by 2, which is pretty ugly. But we do know what all the pieces in here are. They're just not going to lead to nice things. We'll get the square root of 1 minus cosine of 30, where cosine of 30 is one of those common angles. Root 3 over 2. Sorry, there's not a ton of space there to fit what I want, but that's okay. We've got that root 3 over 2, and then we can pull down the 1/2 there, and we get the square root of 1 minus, oh, excuse me, not 1 minus. If I'm pulling that 1/2 down, that can't stay a 1. That becomes a 2. 2/4, find a common factor. In any case, you get this over 4, or if you prefer, root 2 minus root 3, all under a radical, divided by 2. Where, actually, even though it's not at all obvious, this is the exact same as root 6 minus root 2 over 4. And you can come up with some algebraic arguments for why this happens, but kind of interesting to notice that we get two very different looking results that have the exact same meaning mathematically. And we're still learning this stuff, so we're not going to see this a ton of times. Usually we're going to be pushing towards a really specific answer. But it's important to see this now because the nice thing about trig functions is, for how repetitive they are, we get a lot of very differently worded results that have the same mathematical meaning. This is going to be a common theme when dealing with trigonometry. Getting the same answer, just with very different words. In this case, very different numbers. But anyway, that's all we're going to see for 5.3. Next week, we're going to finish Chapter 5, looking at 5.5 with more of this stuff, but in context. In any case, I'll see you then. Let me know if you have any questions.